I'm Cindy Swearingen from the ZFS team, and I'm here talking to Darren Moffett about his ZFS encryption project. Darren, tell us about what you've been working on.
Yep, so I'm Darren Moffett. I'm a senior staff engineer in the Solaris security organization. I'm actually not part of the ZFS team. And I've been interested in security ever since I was a customer, so I'm working for the Ministry of Defense. Did a lot of work on the Solaris encryption framework. I was one of the tech leads for that. And I wanted to put that information to good use, put that technology to good use, and add encryption into ZFS to solve the problems customers have with data in their clear text on their desks. We've already got a solution at Sun for encrypted tape. It's time to bring that further into the enterprise and also solve the problem for people who are running Solaris on their laptops.
So Darren, can you briefly describe what you've been working on?
Okay. So ZFS today already has the ability to compress your data. We can, as of recently, deduplicate it. But every time we write anything to disk, it's written in the clear. And when I demo ZFS Crypto to people, I like to show them how easy it really is. And my typical way is I take a copy of the text to Hamlet, lots of very unique, easy words in there, and then just go and run the Unix strings command over their actual disks. And not only do you see the individual words, you generally see the whole file formatted exactly as you would in your text editor. Mm-hmm. That's how we actually end up writing things to disk, particularly in ZFS because we've got nice big disk blocks. So it's actually too easy to find your data on disk, and it's just not acceptable in a lot of environments. Anything from the stolen laptop to data in an enterprise, you might think it's nice and secure inside your nice brick walls, but sometimes people do break in and steal your physical drives and stuff for various reasons. So what we've been working on is to extend ZFS, keep the same ZFS admin model. It's got to work with all the features and add the ability to encrypt the data when it goes out to disk. And I said we've got to fit in with the existing ZFS admin model to do that.
Okay, great. Can you tell us how to enable encryption on ZFS?
So we enable encryption just the same way as we do compression and checksum or dedupe. It's a property of the data set. So each individual file system can choose whether or not they've got encryption on or off, and we can actually choose what strength of encryption you want to use. There's one very subtle difference. Dedupe, checksum, compression, you can opt in or out of at any time, but for encryption, we want to be sure that all the data in the data set is always encrypted, and they're all encrypted using the same algorithm, so that the same level of strength. So, like we do with some of the normalization properties, it's create time only.
Okay, great. So there's also the flexibility, though, that you can set it per data set or set it on the entire pool by setting it on the top level data set so that the entire pool is.
You can do that. The only time where you can't really set it on the entire pool is if you've got a single disk laptop system, because we can't boot from the encrypted data set.
Sure.
But if this is a data pool, either in an appliance or it's a data pool in DIY open storage, go ahead and set the same policy at the top level of the pool if that's what suits for you.
Okay, great. Tell us which encryption modes are available. Okay.
So it's designed to be extensible, not end administrator or end user extensible. Today we've settled on just using AES, and we support it in the 3 standard AES key lengths of 128, 192, 256. But by default we use AES at 128, and that's what you get if you say encryption on. There's a few extended modes in there for the people who really know a little bit more about the encryption and they want to choose sometimes a performance trade-off between 128 and 256, if that's what you want to do. But for by and large, most people just say encryption is on.
Okay, great. And then when encryption is enabled, tell us about the way that the key can be identified or passphrase.
Okay. So in addition to the encryption property, the other key property we need to look at is this new one called key source. And we don't store the actual key there, because that would get written to disk with the data. And it's where to go and find the key and what format it's in. So today we support the ability for the key to be derived from a passphrase that the user types in. Now this might either be, they'll type it in at the point they create the file system, and we get them to verify it so they hopefully remember it. Because if they forget it, there's no way we can help recover this for them. The other thing that you can do is you can put the actual raw key into a file. And in that case, you want to use one of the existing Solaris key generation tools to probably generate that key for you so that you've got a good key. And you can use something like pktool command, or maybe you've got some external key management system that'll do those for you.
And pktool is included in the Solaris?
Yep,
release?
that's a standard Solaris. So
Great.
you can say gen key with that. But we also allow you can use a passphrase but put the passphrase in a file. So we separate the format of what the key from where it is. And that's all stored in the key source property. The key source property itself is designed to be extensible. So in the future, we could say, connect to this remote key manager system and get your key. And there may be some protocol we use there. And that would, how we do that would be defined by some token or something in the key source property. So again, it's extensible, fairly basic, but very useful just now. And again, in the future, it might well be that on a single user system, the user's login password's used for their home directories, and it's all virtually invisible to them.
Okay, great. And then the way that, because this is property-based, it's enabled through a data set property, then you can determine how or which of your data sets are encrypted by just viewing the property set.
Yeah, just do ZFS get -R encryption, and you'll tell you which one of your ones are encrypted and which ones aren't.
Okay.
Nice and easy.
And finally, do you have any preliminary performance data?
In terms of performance, I'm going to give the usual glib answer that nobody actually wants, but it's the true one. It depends on what your data ingestion rates are, what type of machine you've got. But I have done some basic performance. I'm not going to give you numbers, but what I can say is that comparing the file micro and file macro loads for FileBench, which gives a good range of things, including some OLTP. On a reasonably powerful machine, I did these on an X4500. For a lot of the tasks in those workloads, the overhead of AES 128 encryption was not visible. AES 256 was visible, and in some of them, there was a definite big hit at some points in these. I don't remember off the top of my head which ones it was. So I then thought, well, what's the closest thing we can do to encryption is compression. They're very similar from a mathematics and point of view in the way they're actually implemented in Solaris. So I thought, let's pick gzip9. It has a little bit of a reputation in ZFS of taking away as much of your CPU as you possibly have. So I compared the AES 128 compared to gzip9, and they seemed fairly comparable in a lot of things. And when the surprising thing was when I put them together, the overhead of the AES encryption almost disappeared in the numbers.
Great.
So for some workloads, actually compressing first and then encrypting, you can remove the overhead of the encryption. But at the end of the day, performance numbers depends on your machine and what you've got to spare.
Right.
Yeah. A couple of other things that you didn't ask that I want to say is that, so I mentioned it was create time only. And when we talked before, you said, well, how do we make sure there's an unclear text lying around?
Right.
And that's how we make sure of that is, because ZFS is copy on write, it's really important that we actually can't just say, I've already got a gigabyte of data in this data set, turn on encryption. Because we can do that with compression and dedupe, and it applies to everything in the future, and that's okay. That wouldn't have been okay for encryption, so that's why we made it create time only.
Well, thanks for mentioning it.
Yeah, thank you.
Darren, how does ZFS Crypto use the Solaris cryptographic framework?
Okay, so given that I was one of the lead developers in the crypto framework, it was, as they say, it's a no-brainer that we weren't going to do it any other way. So we use two main pieces of functionality from the crypto framework. We use the kernel interfaces for doing all the AES bulk encryption. And the benefit we get for that is, particularly as we were just talking about performance, is on some CPUs you can actually offload the encryption either to a hardware accelerator, such as like the Sun SCA6000 card, or the current Intel Core i7 processors have the ability to do AES on chip. Crypto framework hides all that from ZFS. ZFS just says, encrypt it, put it in that buffer, and tell me when you're done. And the crypto framework would even allow ZFS to do those things asynchronously if it turns out that's the right way to do it. The other piece of the crypto framework we use is, we use some of the stuff up in userland when we're getting the keys from the users, when we're transforming the passphrases in there. So yeah, we're using a good cross-section of the crypto framework now, and as we add more features for ZFS encryption in the future, we'll be putting more and more demands onto the encryption framework. So very intimately tied together.
Okay, great.